when exploring Mars, we've only seen a small portion of it with the current set of robotic vehicles that we've sent. But there's a lot more to Mars, to it. And one of the interests is in looking for life. And one possible location for life on Mars might be within lava tubes, where they're protected from ultraviolet radiation, cosmic radiation, perhaps a more consistent temperature environment. And those are very difficult areas to get into. It looks like the way you enter them is through what's called a skylight, which is basically a collapsed part of the ceiling. And it's difficult terrain to get to, and then once you're in it, these tubes are probably 200 meters in diameter, so how do you go in them? We started thinking, since one vehicle wouldn't accomplish it, what kind of combinations of vehicles? So a rover that would get you close, and then some sort of aerial vehicle, be it a true aerodynamic vehicle, if it's possible to fly on Mars, or a reaction-powered vehicle, a hopper of some sort, to go into these tubes and explore them. These vehicles are going to have to be able to think for themselves, move for themselves, make decisions for themselves, enter and then leave in a safe manner to accomplish these kind of space missions.
Part of the problem is to integrate information from cameras, visual type information, into a navigation strategy, and to use that to be able to operate without typical navigational inputs like GPS and magnetic compass. We have always flown using some sort of planetary-based navigational aid like GPS, and being actually able to fly outside in a realistic environment without those would be a real milestone in automated exploratory flight for unmanned aircraft.
We've pulled back from as I said, the full robotic vehicle, and basically are looking at software algorithms. We're looking a lot at biologically inspired algorithms. One of the models we use is the honeybee. You know, you have this little insect that can actually navigate up to around 12 kilometers from the hive, avoid spider webs, avoid hitting trees, find a field of flowers to sit there and harvest the nectar from, and then integrate its path back to the hive, and then share this information. Well, that's very much like some of the things that we would like to accomplish. It does it with minimum computing power. And so we're looking at algorithms inspired by biology that would make our tasks simpler. So that's where the research is kind of taking us. Mars is the major goal, but these type of technology in terms of other space exploration would be just as good on some of the moons of Jupiter or Saturn. And there's always the possibility of applying some of it here on Earth in terms of search and rescue missions. You have collapsed buildings from an earthquake, so you don't have GPS signals within those buildings, yet you want to explore them and try to rescue the survivors of the accident. So that's one potential Earth application.